All right, guys, welcome back. Today we're going to be going over 5.4, which is applying trigonometric functions. And for a think/warm-up here, I have using the Pythagorean theorem, which remember is a squared plus b squared equals c squared, where c is the hypotenuse of a right triangle. We can find the third side of a right triangle if we are given the other two, right? So if we are given a and b, we can find c. If we're given b and c, we can find a, and so forth. Using trigonometry, could we find the length of other sides of a triangle if we only have one? So if we only have one, could we find the other two? Well, not using the Pythagorean theorem, right? We'll need at least two, but using trig, and I'm going to bet that we can, but the follow-up question is here is what else would we need? So let's just think of a trig function. The first one that comes to mind to me is sine. So let's just say sine of theta, and we know that's opposite over hypotenuse. Well, let's just pretend for a second that we know one of the sides. Let's say we know the opposite side, right? So sine of theta equals opposite, or let's say we know that opposite side is 5 meters long or whatever unit long. And then we don't know the other two sides, which means we don't know the hypotenuse. What else would we need here to be able to solve to find the side of the triangle if we don't have the other two sides? Well, isn't theta here just like any other replaceable variable? Theta is just an angle, right? So what we would need is we would need an angle and a side. If we have those two things, we can find another side of the triangle. And then if we have two sides of the triangle, we can find all three with the Pythagorean theorem. And that's what we're going to be going over today. So example 1, if angle P equals 35 degrees and R equals 14, find Q. And here we have it nicely drawn out for us. We have our angle P being 35 degrees. And what I'm going to do for these is, so I'm going to be thinking of our, I'm not even going to write specifically. I'm just going to be thinking of our different trig functions, right? So we have sine is opposite over hypotenuse. We have cosine is adjacent over hypotenuse. And we have tangent equals, tangent of theta, I should say, equals opposite over adjacent, and that's from SOHCAHTOA. Right? And now I'm going to be looking at what I have in relation to the angle of interest. So when I say angle of interest right here, angle P equals 35 degrees. That's what we know. That's what we're looking at. So, and now in relation to angle P, what are the sides that I have and what are the sides of interest? So the first one, I have this side, R equals 14. I have that side. And what side is that in relation to angle P? You might initially be thinking, oh, it's adjacent, but we need to remember that that side is across from the right angle. So this side is actually the hypotenuse. And now it's asking us to find Q. So what is Q in relation to angle P? Well, opposite would be across, which is P, and right next to it should be adjacent, right? So in relation to the angle we're talking about, which is angle P, we have information about the hypotenuse, and we're looking for the adjacent side. Find Q. We're looking for that adjacent side. So I'm going to pick the trig function that involves both the hypotenuse and the adjacent side, right? So which ones do that? Looks like cosine does, right? Cosine has the adjacent side and the hypotenuse. So I'm just going to plug in what I have now. Cosine of theta, which is an angle, which we have, right? Cosine of 35 degrees equals adjacent, which we don't know. Adjacent is Q, over hypotenuse, which we do know. The hypotenuse length is 14 right there. right? And now it's just a basic algebra problem where we solve for q, right? We're dividing by 14, so we need to multiply both sides by 14. And so then we get 14 times the cosine of 35 degrees equals q. And if we punch that into our calculator, you should get about that q equals 11.4681. And I guess if we're not being fully accurate, we can write these two little squiggly lines, which means approximately or about. And that's just from typing 14 times cosine of 35 degrees in our calculator. And that's the answer to that question. So this next one is more of a word problem, and we kind of just need to learn how to dissect a word problem and create a picture, even though it already has one for us. And we're going to use that same exact tactic that we just used. So example 2, the circus has arrived, and the roustabouts must put up the main tent in a field near town. A tab is located on the side of the tent 40 feet above the ground. So if I were making my own, I'm thinking above the ground. All right, if this is the ground, let's just go above the ground, right? And that length will be 40 feet to the top. And a rope is tied to the tent at this point. So at the point where that tab is, that imaginative tab, a rope is tied to it, and then the rope is placed around a stake on the ground. So down there somewhere on the ground, we have a little stake. Maybe I can draw something there. There's our little stake put on the ground. If the angle that the rope makes with the level ground is 52 degrees in 15 minutes, so that one is saying that this angle right here is 52 degrees and 15 minutes. How long is the rope? What is the distance between the bottom of the tent and the stake? So the rope we know is here. I'm just going to label it R because I think that's a good name for the rope. And then the second question is, what is the distance between the bottom of the tent and the stake? And I'm just going to call that distance D. So this would be the bottom of the tent. Here's our stake. I'll just call it D for distance. And that would be me sketching a picture. Luckily, our book kind of sketched a nice one for us, so I'm going to erase mine. But if you have to create your own picture, that's how you want to be thinking and dissecting those word problems. But for this one, it's given us a nice drawing. Same thing as mine, it just has a nicer picture, right? So we're looking for R and D. And again, we have this angle here, right? Let's call this angle theta, just so we have something to call it. And again, we know that sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over adjacent. And so I'm going to look at this angle and I'm going to see what we have going on, right? So we know that this is the opposite side. And this looks like the hypotenuse. And down here, D looks like would be the adjacent side. So we're looking for both the hypotenuse and we're looking for the adjacent side. So we kind of just have to pick one at first to go for. And just for the sake of it, I'm going to go for the adjacent side, right? So what do we have for this triangle in terms of an angle? And with respect to that angle, what sides do we have if I'm looking for the adjacent side? Well, I'm given the opposite side, And if I'm looking for the adjacent side, I need the trig function that then involves both the opposite side and the adjacent side. And which one is that? That would be tangent of theta, right? Because that has opposite and adjacent. Opposite and adjacent. So tangent of theta is going to turn into tangent of our angle that we have, which is 52 degrees and 15 minutes. Ooh, that might be tough to put in a calculator, right? So we're going to have to do 15 times 1/60th to put it in degrees. And that's going to be 0.25, right? Probably don't need a calculator for that one. 15 times 4 is 60. So that'll be 1/4 or 0.25. And so if we have tangent of 52? Yeah, 52.25 degrees. That is going to equal opposite, which is 40 feet. Opposite of this angle, 40 feet. All over adjacent, which is what we don't know. All over adjacent. And so now this is another one that you just punch in your calculator after you solve for it algebraically. So if we multiply both sides by a, we're going to get a tangent of 52.25 degrees equals 40. And then we're going to need to divide by tangent of 52.25 degrees on both sides. And so then we're going to be left with a equals, and guys, don't let this tangent of 52.25 degrees freak you out, right? That is just some number. All that together is just some number, right? Just punch that into your calculator and then do 40 divided by that. And when you do that, you should get that. Let me get my calculator real quick. So let's do the tangent of 52.25 degrees. And then I'm going to do 40 divided by that number. And that is going to get me that A. And then I shouldn't really put equals. I should put that A is about 30.97, right? And then this is a side length. It's not in degrees, right? This is the side length. This is this side length right here, 30.97, right? So not in degrees. And so that is the length. What is the distance between the bottom of the tent and the stake? That's our D actually. So I'm going to label it D down here because that's what we have it labeled right here. But it is the adjacent side. So now we need to find the hypotenuse. But notice after we found the adjacent side, now we have two sides, right? Now we have this 30.97 and we have this 40. So now we could just use the Pythagorean theorem to find that third side. And the third side being hypotenuse, we would just do H for hypotenuse, or in this case, it's the rope. So R equals the square root of 30.97 squared plus 40 squared. And then when we punch that into our calculator, square root of 30.97 squared plus 40 squared gives us that R is about 50.588. And that's also an approximation. And those are our two answers for that one. And the next section of this, we're just going to go a little more over some word problems that might be a little more in depth than these other two. But that should cover today's lesson on applying trig functions.